All right, welcome to Trig Identities, Expressions, and Equations. First of all, we're going to talk about what is meant by an identity, and then we're going to talk about quotient identities, Pythagorean identities, and double angle identities. We're going to wait on the negative angle ones for the moment, but we're going to talk about this so we can work on it in class. All right. So the first thing I want to show you here is we know what an identity is. An identity is an equation that is true for all x's. So basically, if you want to figure out what an identity is, if I manipulated one side of the equation and got them to work and match, I usually use a check mark with a little dash in it. If each side matches the other side, then that's an identity. Okay. Identities we've seen. Well, so far we've seen that tan theta equals sine over cosine, secant theta equals 1 over cosine, cosecant theta is 1 over sine, and we've had cotangent equals cosine over sine. And then we've got Pythagorean identities, which are sine squared plus cosine squared theta equals 1. And then if you divide each of those terms by cosine squared and then again sine squared, you'll come up with these other two identities, which is 1 plus cosine squared theta equals cosecant squared theta, and tangent squared theta plus 1 equals secant squared. Now, you do have in your packet this identity sheet. And if I put it on the first page, you'll see what I just went through. These are the reciprocal identities. Here are your quotient identities, where you have tan theta is sine over cosine and cotan is cosine over sine. And then here's your Pythagorean identities, where here is your main identity, which is cosine squared theta plus sine squared theta equals 1. And then by manipulating it, I get these other two. So please refer to this as you're going along. The other things I have on here are alternate forms, where if I have this basic identity, I can solve for either cosine squared or sine squared. And then I have alternate ways that you can write the reciprocal functions. On the back is going to be, we're going to talk about difference of angle measures, the sum of angle measures, and then double angle. And if you'll notice for double angle measures that sine theta has 1, and you'll notice double angle because it'll show a 2 inside here, that if I have the sine, I have one formula only, and tangent only has one form, but cosine of a double angle has 3 different forms. All right, so let's go back to our notes. So you can stop this at any time if you need to fill it in. All right, the first thing I want to do is show you how to use this when we are actually solving equations. So if you'll notice, I have this here, and you can stop the video to copy this if you'd like, but I have 4 cosine squared theta of x equals 3 plus 3 sine x. And notice I have a cosine squared and a sine. They're not the same. So what I want to do is to replace one of these so that I can get this all in one trig function. And I notice it's cosine squared. So if I use this identity, sine squared x plus cosine squared x equals 1. And if I move the sine squared over there, I'm actually solving for cosine squared x. Okay? So now I can say in this spot, cosine squared x is 1 minus sine squared. And then I distribute it. All right, so you guys distribute this. So now I have 4 minus 4 sine squared x equals 3 plus 3 sine x. And then I just moved everything over to the right so that I would come up with this equation. Now, you have been doing these in class, but now you're actually manipulating them using identities to get to the point where you can solve it. Once it's in this form right here, I can stack and rack and actually solve it. Now, we've been doing a ton of these, so let's go through this. So I do the sine of x equals negative b plus or minus the square root of 25 over 8. Split it up, plus and minus. When I do negative 3 plus 5 over 8, that's 1/4. Negative 3 minus 5 over 8, that's negative 1. And so now I know sine is positive and then it's negative, but I know that this is a quadrant. Okay, so if I looked at the negative 1 right off the bat, and if I did inverse sine of negative 1, you're going to see that this right here, and I'm using this picture down here, is down here at 270 degrees. So that's what goes with this one. When I do inverse sine of a 4th, I know sine is positive in quadrant 1 and 2. I get 14 degrees, and then I know if I subtract it from 180, I get 166 degrees. So I actually end up with 3 answers, 14 degrees, 166 degrees, and 270. Now this one over here on the right, if you'll see, I factored this one, but I noticed that it had a 2 in here, and they're both sine, but this is a double angle, so I actually had to replace that. So I went over to my sheet, of all my identities, and I looked at the double angle one. It says, okay, if I have the sine of a double angle, it's 2 times the sine of the angle, cosine of the angle. So I went back and I actually put that in that spot, equals sine. Now the only thing that bugs me a little if I have a cosine there. So I got it, if I can factor it out and get it separate, then I can work on it. So I moved the sine over here, and then I factored the sine out of both terms, because this is a term here and this is a term here. And when I do that, I have sine x equals 2 cosine x minus 1 equals 0. So now I have sine of x equals 0, and I have 2 cosine x minus 1 equals 0. This comes out to be cosine of x is a half, and it's positive, and I know cosine is positive in quadrant 1 and 4. So if I put inverse cosine of a half, I get 60 degrees, and then in the fourth quadrant it would be 300. Now over here the sine of x is 0, so that means it's on a quadrant, and so I know it's 0 degrees or 360, and over here it's also 0 at 180 degrees. So I have 3 answers for this one. So this one actually ends up with 5 answers. You have 0 degrees, then you go 60 degrees, 180, 300 degrees, and 360. That's if 0 and 360 are included. Okay, now this next one is we're going to show the following are actual identities. So basically what you're going to do is prove that the sides match. And when you do that, I usually tell students to go to the side that looks the worst and see if we can manipulate it. So I look over here and I see this is 1 plus a sine. This is a double angle, so I know I know that the sine of a double angle is 2 sine x cosine x, and if I can get that to show up over here somewhere, then I know I've got them to match. So I actually first multiplied this out. So I have sine squared x plus 2 sine cosine x plus cosine squared x equals this side. Now I look at it, I say, oh, sine squared of x plus cosine squared of x equals 1. So this side is 1 plus 2 sine x cosine x equals 1 plus sine 2x. Now if I look at this, I go, oh, that is a double angle. That is the sine of a double angle. So I can say, oh, these sides do match. 1 plus the, of sine 2x. This is the sine of a double angle equals this. And I got both sides to match. So I've proved my identity. I show a little check mark with a line through it. Now let's look at this one over here. I have a cosine of a double angle. I have a double angle here, so that's got to mean if I have a double angle, I've got to use my sheet here and actually plug it in. So I'm going to go to my sheet again and look at it to see if I have what I can have for a cosine of double angle. And if you see, I have 3 of them I can use. And I'm like, which one am I going to use? Well, I actually picked the first one here because the denominator has a cosine and a sine in it, and I'm wondering if something will cancel nicely. So if we go back to our sheet, I said, all right, I'm going to write down that cosine squared x minus sine squared x is the cosine of the double angle, so I use the first one. And look at the denominator. I'm thinking if I can factor the numerator, this side will come out nice. Let's see how it works. Now if I take the top, that's the same thing as front seat, back seat, so it's cosine x, or the difference of 2 squares, and it's plus sine x. I'm kind of running a room over here, see if I can equals the cosine of x minus the sine of x. And when I do this, I see that these can cancel and make a 1, so I've got it to match. The cosine of x minus the sine of x equals the cosine of x minus the sine of x. And I got my identity. I proved my identity. All right, so let's look at the sum and difference of sine and cosine formulas. So basically what you're doing here is if they say find the exact value and it's not on the chart or the table we had mentioned, and when I did exact value chart, we did the basically first quadrant we did the first quadrant, and we did all your quadrantal angles. And if they ask you to find the exact value of an angle that's not on there, you can use the sum and difference formulas to find it. So let's look at one that we're going to do together, and we're going to practice more in class. Is if I wanted you to find the exact value of the cosine of 105. Okay? Well, 105 is not on my chart, but I do know that 105 I can write this way. I can write it as the sum of two angles on my chart, so I have 60 plus 45, and both of those are on my chart. Now, here is the sum of angles. Now, if we go to our paper that I gave you, and if I look for the sum of angles, and I'm looking for the cosine, if you'll see, there's a formula for the cosine of the sum of two angles. And what you do is you have the angle here is in the A spot and the B spot, and then we're going to plug it in. So we're going to use that formula to actually do this. So I'm going to write it like this. The cosine of 60 plus 45, okay, is, now we got to find the formula first. So I did the cosine of angle A plus B equals the cosine of A plus the cosine of B minus the sine of A and the sine of B. So I always have people put the A here and the B here. So I end up having the cosine of 60 degrees plus the cosine, times, this is not a plus. Let's try this again because this is not working out right. Let's try this all over again. First thing I want you to do is write the formula down. So the cosine of the sum is A plus B equals cosine of A, cosine of B, it's multiplied, not added, plus, minus the sine of A, sine of B. Okay, now we finally got that right. I do apologize. Now we are trying to find the cosine of 150, which we said is 60 plus 45. So in the A spot, we're going to put all 60. So we're looking for the cosine of 60 plus 45. And in the B spot, we're going to put this. Now I'm just going to plug it in. So this is the cosine of 60, the cosine of 45, minus the sine of 60, sine of 45. So the cosine, the exact value of the cosine of 105, which I know you can put in your calculator, is the cosine of 60, which we know from our table is 1/2, times radical 2 over 2, which is the cosine of 45, minus radical 3 over 2 times radical 2 over 2. So notice I used all the exact values from my table to find the exact value of something that is not on my table. So when I multiply that, I got radical 2 over 4 minus radical 6 over 4 equals radical 2 minus radical 6 all over 4. That is what the cosine of 105 degrees is. Well, that concludes our trig practice for this. We'll practice some more sum and difference formulas in class.